Touchdown confirmed.
On February 18th, NASA's Mars 2020 mission touched down on the Red Planet. Since then, its Perseverance rover and Ingenuity helicopter have been exploring the terrain and sending back never-before-seen images and video of the Martian surface.
The Mars 2020 mission, Mars Perseverance, has had a string of firsts. The first sounds from Mars. We can now hear the wind on another world. More practically, it is the first test of a new onboard navigation system that gives a rover on Mars greater independence in how it can guide itself around potential hazards.
Jennifer Trosper is NASA's Perseverance project manager. She's been working on the mission for the past 7 years.
We took along 2 technology demonstrations. One is an instrument called MOXIE that actually uses the carbon dioxide atmosphere and then produces oxygen. And then, of course, the other technology demonstration that we have been successful with is showing that you can fly helicopters on Mars.
Now, after over 10 months on Mars, what have we learned from Perseverance and Ingenuity that we didn't know before? And are we any closer to figuring out if Mars has what NASA set out to find? Signs of ancient life. One of the most important milestones took place in mid-August when Perseverance began collecting rock core samples. NASA is planning to retrieve Perseverance's Martian rock samples with another spacecraft, which is expected to launch from Earth in 2026 and arrive at Mars in 2028.
One of the big unanswered questions that NASA faces in its search for life and the collection of these samples on Mars is, can we muster the will and the funding and the engineering expertise to actually bring these samples home? Right now, there are plans on the drawing board, there are speeches, there are intentions, but it's a long time between now and the 2030s when these missions that are being projected, being talked about to bring these things home.
In April, the Ingenuity helicopter became the first craft to fly in the atmosphere of another planet.
This technology demonstration was one for the history books.
The next flights tested the helicopter's ability to move horizontally, and it covered longer distances in each subsequent flight. Ingenuity has now flown 18 times.
When we get over to the Delta, Ingenuity can, again, be used as a scout to really point Perseverance to the best places scientifically to go. I think if she's still living, we have lots of opportunities for scouting as we move forward in the mission.
NASA selected Jezero Crater as Perseverance's landing site because it gives the rover access to a large stack of rocks that sits at the end of a dry river valley. Based on satellite images, scientists have theorized that these rocks are made of sediment deposited by an ancient river that flowed into a lake roughly 3.5 billion years ago.
So Jezero Crater is essentially, if you're looking for signs of ancient microbial life on Mars, this is a place to go.
NASA selected its landing site because scientists have long suspected the area was once covered in water and therefore had the potential for the development of life as we know it.
Applicant indicates chute deployed.
Perseverance landed more than a mile away from the cliffs at the front of the Delta and started taking high-res pictures to survey the distant rocks.
We basically looked at the different stratigraphy that we saw and wanted to confirm that we were right, that this really is a delta with a river inflow and it was deposited and there was a lake here.
On October 7th, NASA scientists published the mission's first study in the journal Science, based off those images. The study found that for potentially millions of years, a river flowed into a lake that filled Jezero Crater.
We actually have a set of samples that is very good for the lower crater area. We have 4 core samples. We will have 30 that we can return to Earth. We'll collect more than that and then we'll down select. And that Earth return is in the early 2030s.
In December, NASA scientists confirmed yet another long-held suspicion, that the Martian bedrock on which Perseverance rover has been driving since February likely formed from red-hot magma.
This was a big surprise to us. Certainly not what we expected to find, that these are in fact volcanic rocks.
This is Perseverance project scientist Ken Farley speaking at a recent conference about the finding.
This was completely unexpected and we are struggling to understand what it means.
Although it landed on the Martian surface in February, Perseverance's sample return mission has only really just started to get underway.
Well, the core samples are the hard evidence, and I do mean hard evidence, of something that we have been speculating about for the longest time. We want to have some tangible evidence, something that we can put under a microscope, something that we can run genetic samples on, something that we can prove beyond a shadow of a doubt is not the product of our creation, but is the product of a separate creation on another world.